When this video starts, it might look like just another rocket test over the ocean, but this one is different. What you're seeing is China testing the core hardware. This test is part of China's long-term plan to send astronauts to the moon, possibly before NASA's next landing. On February 11th, China carried out an important flight test at the Wenchang Space Launch Site. This mission was the first time China tested its new lunar cruise system in flight, combining multiple goals into one launch. The test involved two main elements: a prototype version of the Long March 10 rocket, a prototype version of the Mengzhou crew capsule, China's future spacecraft for moon missions. Both the rocket and the capsule were still in testing form, not final operational versions. Before this flight, engineers had already tested the rocket's engines while it was held down on the pad, and the capsule had completed a ground-level escape test. This launch was the first time everything came together in the air. At around 11 a.m. China Standard Time, the Long March 10 test rocket lifted off with the Mengzhou capsule on top. The rocket was powered by 5 kerosene and liquid oxygen engines, pushing it upward through the atmosphere. Shortly after liftoff, the rocket reached one of the most stressful moments of any launch. This phase is called maximum dynamic pressure, or max-Q, when the forces on the rocket are at their highest. That is exactly when China triggered the most important part of the test. During max-Q, the capsule's escape system activated on purpose. Powerful motors fired and pulled the crew capsule away from the rocket while the rocket's engines were still running.
If you enjoy deep-dive science documentaries like this, focused on real data, real mysteries, and the edges of human knowledge, consider subscribing. New videos explore the universe where certainty ends and discovery begins. And let us know in the comments what you think. Thanks for watching.
This test simulates a worst-case scenario, something going wrong during ascent when astronauts have only seconds to escape. After separating, the escape system reoriented the capsule for descent and detached. The capsule then deployed small parachutes first, followed by its main parachutes, and splashed down safely in the ocean. This confirmed that the capsule can protect astronauts during the most dangerous phase of launch. While the capsule was descending, the rocket booster continued flying for a short time. It shut down 2 of its engines, adjusted its trajectory, and reached just below the edge of space. On the way back down, the booster deployed grid fins to control its descent. Some engines briefly restarted to slow it down before it finally splashed into the sea. Nearby, an automated recovery ship tested its systems for future booster retrieval. China is experimenting with a net-style recovery concept, where a descending rocket could be caught instead of landing on legs. This approach is different from SpaceX's method and is still in early testing. This single mission checked many boxes at once. It was the first flight test of the Long March 10 prototype, China's first high-stress escape test at max-Q, the first ocean splashdown of the new crew capsule, the first test flight from a new launch pad, a major rehearsal for future recovery operations. More importantly, it showed that the rocket, spacecraft, escape system, tracking, and recovery teams can all work together in real conditions. China's goal is to land astronauts on the moon by around 2030.
One Long March 10 rocket will launch the Mengzhou crew spacecraft. Another Long March 10 will launch the lunar lander, called Lanyu. Both spacecraft will travel toward the moon and enter lunar orbit. Once there, they will dock together. 2 astronauts will move into the lander while one remains in orbit. The lander will then descend to the moon's surface. After completing surface work and collecting samples, the astronauts will launch back into orbit, dock again with the crew spacecraft, and return to Earth. The moon is about 380,000 kilometers away, far beyond low Earth orbit. Reaching it requires much more energy, fuel, and precision. China's current rockets are not powerful enough for crewed lunar missions. That's why the Long March 10 is being developed. It is designed specifically for heavy payloads, high reliability, human safety, and precise orbital insertion. The rocket must also be accurate enough that two separate launches can meet and dock near the moon. The Mengzhou spacecraft is larger and more capable than China's previous crew vehicles. It can support missions beyond Earth orbit, has stronger propulsion, more space for astronauts, and improved life support systems. The Lanyu lunar lander is designed to handle the moon's harsh environment, including extreme temperatures, rough terrain, and low gravity. It must land autonomously, avoid hazards, and later launch back into orbit. China has already conducted ground-based landing and takeoff simulations for the lander, using sensors and automated guidance to mimic lunar conditions. This test does not mean China is ready to land on the moon tomorrow. Many more tests are still needed. More rocket flights, more spacecraft validation, lander testing, docking demonstrations, re-entry and recovery trials. But this test shows real progress. Each successful test reduces uncertainty and risk. Step by step, China is building the systems needed for a crewed lunar mission. If you found this breakdown helpful, subscribe to the channel for more clear explanations of space missions and discoveries. And let me know in the comments what you think. Do you believe China will land humans on the moon before NASA?